Welcome to the first video tutorial of Module 2. In this tutorial, we will explore how biorefineries will convert common agro-industrial waste and byproducts into value-added products using biotechnology. Currently, our environment is facing a tremendous crisis due to global warming and the depletion of fossil fuel resources. In the meantime, we throw away more than 1 billion tons of food globally every year. That intensifies societal challenges. Across all stages of the food supply chain, from farms, food manufacturing process to storage and delivery, several unavoidable waste and byproduct streams are generated. But, could you imagine that these discarded food industry byproducts or the food you discard could be transformed into fuels, plastics and electricity, helping to mitigate the environmental crisis? Imagine the idea of your candies being colored or your bread fortified with compounds that derive from agro-industrial byproducts and microorganisms. Welcome to the world of biorefineries and their position in bioeconomy framework, where agro-industrial waste and food byproducts are transformed into specialty products aiming towards clean label products. This module will focus on the use of biotechnology, especially microorganisms, to utilize renewable resources and generate value-added products. We will also explore conventional, emerging and green techniques for biomass processing, including extraction, fractionation and downstream processing. Biomass is defined as the renewable organic material that derives from plants, animals, or recently living organisms. It includes an ample range of resources, like agricultural crops and residues, wood, algae, and food waste. Biorefineries operate in a similar way to a traditional oil refinery, but instead of fossil fuels, they utilize biomass as onset material through chemical, biological, and enzymatic processes. Biorefineries are key enablers of the circular economy, where nothing goes to waste, but most importantly, have a significant impact to support bioeconomy. The composition of biomass is extremely diverse, consisting mainly of carbohydrates, protein, lipids, and valuable components like phenolics. Follow us as we examine the numerous compounds that can be extracted from biomass to be utilized for different applications and market outlets, like food, pharmaceuticals, and cosmetic industry. Join us to explore how a huge number of microorganisms, like bacteria, yeast, and fungi, can utilize the carbohydrates and protein fractions present in biomass to synthesize different metabolites through microbial fermentation processes. Fermentation technology has been long used to manufacture a variety of products for the food and the pharmaceuticals industry, like beer, whiskey, yogurt, cheese, kefir, antibiotics, enzymes, but also industrial chemicals like butanol, acetone, lactic, citric, and succinic acid. But what if we were able to leverage microorganisms to our benefit and generate an ample range of end products while substituting conventional substrates in traditional fermentation processes? These bio-based products have the possibility to substitute the conventional chemically derived products applied in the development of functional foods and provide health benefits while supporting the resilience of food systems. In this course, we will break down the different types of renewable resources that can be used in biorefinery design, like agro-industrial waste, food industry byproducts, and post-consumer food waste. We will evaluate how, instead of ending up in landfills, these resources can be upcycled to value-added products through biotechnology. Biorefineries are already shaping the future and demonstrate environmental and economic benefits and positive social outcomes. Lower emissions, the creation of new jobs, energy security, cleaner cities, and enhancing the resilience of food systems indicate part of the impact. In this course, we will delve into the design and development of biorefining projects, biomass types, different end products and the potential applications, the economic and environmental benefits, along with circular economy and bioeconomy policies. Biorefineries are demonstrating that waste and byproducts are not a problem, rather than an unlocked resource for the future. From agricultural residues to the food we throw away, it is all about rethinking waste and highlighting opportunities and challenges using biotechnology. So, having in mind that 1/3 of our food is wasted, Next time you throw away your lunch, just stop and think all the possible products that you toss in the bin. So join us in this module on sustainable food systems and alternative protein sources, and follow us on the Bioshield project website and social media.